Hello, this is just a real quick bit of help with the review sheet for our celebration, which will be tomorrow. All right, I'm going to show you how to set up certain ones. The foist one will be number 6 here. Number 6 is the one that you will have to quadraticate to help you guys solve. So remember, what it says in number 6 is the sum of the two Q's is 600 microcoulombs. So that means Q2, or pick one, it doesn't matter, is equal to 600 minus the other one. Once you have that set up, you put it in the force problem. The force equation is equal to KQ1 Q2 divided by D squared. And remember that Q2 is 600 minus Q1. All right, so once it's 600 minus Q1, you got it set up, multiply the D squared over, and you end up with one side of the equation, force times the distance squared is equal to 600 microcoulombs times KQ1, which is just distributing the KQ through the parentheses, and then minus KQ1 squared. And once you have a Q1 squared and a Q1 by itself, you have it set up, rearrange it so you can quadraticate. And the two answers to the quadratication are the two charges. All right, then we can take a look at, I just set up number 8 for you. For number 8, you are going to have to look up some items. The mass of a proton, if you remember, is 1 atomic mass unit, 1 U, which you can find online. It's just 1.66 times 10 to the negative 27th kgs. It's not a number you need to memorize, but it's one you can look up. All right, the charge of a proton is something you should know. You know, it's 1.6 times 10 to the negative 19th coulombs. All right, so remember, what this one is looking for is forces, right? But an electric field is the K times the big Q that's exerting that field divided by however far you are squared from it. If you multiply that formula by the Q, which is the object that is floating around inside that electric field, then you have a K Q1 Q2 over R squared. That's the formula for the electric force of attraction or repulsion. So that force is equal to this E times the Q, and it's also equal to an MA. Someone should make a law. So what you'll do in this one is set up MA is then equal to EQ, put the numbers in, and you can solve it pretty simple. It's not too tough once you see it set up. You'll use that same strategery for number 10, right? Number 10 is sum of the forces in the Y. It equals MA. MA has to go away because it all adds up to nothing. So that electrical force minus the gravitational force is what war is good for. So the EQ is equal to mg in this case, the same way as the EQ was equal to MA in number 8. All right, so that one was 10. To set up number 12, you have to say, hi, Ed, delta V is equal to Ed, right? So the electric field is the change in voltage divided by the distance, and the force, again, is equal to EQ, which is something we saw in number 8. So that force is equal to this E, delta V divided by D, multiplied by the Q. And when you do that, you'll solve for the F. That's pretty simple. For part B, again, it's Newton's second law. The acceleration is the force divided by the mass. All right, for 13, you had to look up another number, the mass of an electron. Again, it's not something you need to know, but it's one that if you need to obtain, you can just look it up. It's 9.11 times 10 to the negative 31st kgs, not a lot. Remember, work is a change in energy, right? So work, what you know is Q delta V, is in this case a change in kinetic energy. So it's 1/2 mvf squared minus 1/2 mvi squared. Again, you'll get a negative number. That means the electron is losing energy when it comes to rest. Remember that Q delta V, that V represents the voltage. This V represents how fast the item is going. And boy, there's a lot of V's out there, aren't there? All right, so there's that. Also, don't forget we want to talk about electric field lines. When you draw them, don't forget you have an axis of symmetry for charges that are the same. You always just ask yourself, what would a positive do? All right. To review that, you have the worksheets, some of the homeworks. Look those over. If you are also interested, there are 2 PhET activities. One of them is called the Electric Field of Dreams. and the other one is called electric field hockey, which again is just practice drawing those. Anyway, you know it'll take a lot more than a little snow to stop physics, right? We will see you tomorrow with our celebration.